Hello everyone, how are you all? Welcome back to the channel again. I hope all are you good and learn something new with day by day. So today with a new video, I have a phone for repair. This phone is a Vivo Y15s, right? Vivo Y15s. This phone had a problem on a charging issue, regarding charging issue. It's already repaired, I will tell you. And actually, I'm already diagnosed this phone. Where was the fault? Because in my shop there is a lot of work, so sometime I forget the make a video, because make a video is a consuming time process. So sometime I'm neglecting this, because if you can fix a phone in 10 to 15 minutes, suppose, but in according to the video, I will show you a diagnosis process, not a shortcut. When you had experience, you can jump directly to the shortcuts. But while on the video, you will show the diagnosis process from starting to the end, right? But on the reality, on the table time, when you had a good experience, you know that there is a 3 or 4 step for every repair. Right, so you directly jump on these steps. So that's why it's a time-consuming process. So I am neglecting it sometime. But I've already fixed this phone. But I'm removing the solution because I thought make a video on it from starting to the end. Now this phone had a problem related to the charging issue. First, I will show you what was the problem. So on your right side, on the top corner, there is a multimeter, also a charging ampere meter, as in my every video. So we connect a cable. Now it's in a off condition, turning off condition. Right now I'm connecting a charger, and you will see it's taking a charge. Right, 0.200 milliamp, 300. Right, and the logo appear, charging logo. Sometimes 400 milliamp. Right, now after that, when the screen light goes off, it's not taking any ampere, because as I already told you in my previous video, my multimeter is my USB ampere meter is a 5 digit, so it shows a minor consumption also. But when you connect on a normal USB ampere meter, it shows nothing. Right now, when we press the on off button, it shows the percentage, right? Like 53%. But when you look at the ampere meter, it's taking 200, 300 milliamp, right? But when the light turn off, I mean to say in a sleep mode, it's does not take any ampere. I mean to say it's not taking any ampere. Okay, so in your off condition, it's not charged. When you press the on off button, I mean to say when your light turns on, your screen turn on, that time it's taking consumption. Otherwise, it's not taking any consumption when it's on a sleep mode. On a turning off condition, let's turn on the phone first, and after we connect again the charger. So I'm pressing the on off button and it's turned on. Wait for a completely turn on. Actually, it's I'm already had a solution. Or if you go to the YouTube, you will see there is a solution also. Right? I'm clearly telling you there is a solution. But how this line work, how the solution comes, nobody tells you. There is a 2 type of technician, I will tell you. First of all, no, the phone is turning on. After testing, I will show you the charging. After I will talk to you. Now in our turning on condition, I am connecting a charger again. Now it's taking 400, 300, 0.200 milliamp, and its charging shows when turn off screen. It goes to 0.300, 400, roundabout. But the minimum consumption is actually about 0.600 milliamp. After that, it goes to the 1 amp, 1.2, 1.8, that kind of the charging, right? The normal basis scenario. But it's taking, now, look at this. Now the screen is turned off and it's taking another thing, 0.02. Now it's taking 0 to 100. So it's fluctuation between a consumption, actually it's a consumption shows, but not the charging. Now when you press the on off button and the screen turn on, right? Now it's taking 0.500 milliamp, right? That means this consumption actually is from the phone uses like a screen. Right now screen is blinking. That's why it's taking consumption 0.600 milliamp. All right, but not cross the 0.600 milliamp like 1 amp or basic normal charger. Now it's screen off and it's disconnecting. I mean, it's dropped the consumption. In an on condition, still the same fault. In an off condition, still the same fault. Now, how this problem comes, I will tell you each and everything with the full detail. First of all, as we talk about it, there is a two type of technicians. One, they get the solution on a YouTube, right? They get repair because they know the schematics, they know the fault finding, right? And he has also a good hand skill. Now, second one is he had a good hand skill but does not know the fault finding, does not know about the schematics. They can install ICs, right? If the phone fixed, that's okay. Otherwise, it's go to the YouTube. And if a video on a YouTube, a solution, they applied. If the first solution apply, then okay. Otherwise, go to the second solution, third solution, fourth solution. If the phone fix in between these solutions, right? Looking at the YouTube video, they will fix the phone and pack and give it to the customer. If you go to the number one, actually main technician, they know the fault finding, they know the schematics. That's why he fault the find. It goes to the step by step and for the find. Actually, he know that why this fault comes, which line had a problem. So in this video, I will tell you like a full detail why this phone had this kind of problem and this kind of situation. Now, if you go to the second technician who had good at skill, but suppose this phone had a solution in YouTube, a similar phone or another model had a same problem, but does not have his YouTube solution. So the second one does not fix the phone. But if you know the schematics, if you know the how to trace a step-by-step fault finding, you will clearly repair this phone. Let's again correct the charger and see the situation. Now it's taking similar 200 milliamp and the charging logo appears. That's why, that means it's in a same condition. The charging percentage is also shows. When the light turn off, it's drop the consumption. Now we remove the motherboard and I will show you in a microscope.
She said to not in a photo.
And just remove the cameras. Now, look at this motherboard. I will show you. This had already repaired. Near the CPU, there is a charging IC. Someone cut the shield. And I will show you in a microscope. Let's go to the microscope. So, under the microscope, let's see. Now, you will see there is a shield removing. Someone remove the shield. And look at how this removes shield. It's terrible. right? All the first line, I mean to say first layer, clear, remove with the cutter. Look at this here, right? Look at here. Just a sec. Clearing cap. Now look at this on this side shield, right? How terrible, right? This is not the way to remove the shield, right? When you use the cutter like this, right? You can use it if you know the trick, right? But if you know the trick, you just cut it the shield and peel it. You will see the layers cut it. The many tracks are open, right? Look at here. This side also. So it's not a good thing, right? Look at here. I've already made a video about the shield removing. How to remove a shield in a safe way without harm the CPU, REIC in a proper way. So it's looking also a good. When you're removing a shield in a professional way, it's looking good, nice, clean work. But if you use this kind of methods, it's dramatically, you can say, it's not good. When you can't fix the phone, when this phone come to the any other a good technician, who will think, what about you? I mean to say about this person, right? Even they did not fix the phone, even they created another problem in it. Now we're diagnosing the phone, right? So first of all, we go to the born new, right? And starting with because this phone had a VBUS, I mean to say charging issue, so we diagnosing through the charging section, charging lines. So we already open a born new, right? Now in this born new, this is the model, and I'm already open, and this is the hardware solution lines. So first, after the charging connector, the VBUS comes here. So first check the VBUS. Just a second. Right, I'm fixed the motherboard. And after we check the VBUS line, I'm just connecting a charging flex here. I'm connecting the charging flex and the motherboard, right? Now we add a born new here. Now on this point, right, this one, the upper one, you get a 5 volt. Let's connect the charger right. Now in the body, this point had a VBUS line, right? So we connect the charger. Right here, the charging consumption start. Now in a multimeter, in a diode mode, okay. But first we take a voltage. Now on this point, there is a VBUS. So I'm checking the VBUS, right? Yeah. Now it's taking just a second, connecting properly. A 5 volt, right? That means the charging flex, this one, right, and the charging subboard is completely okay. Clear? Because the 5 volt is here. Look at here. That minus 5 volt you will see because I'm checking with the black probe. Because I'm using a black probe mostly in a diode section, on a diode mode. That's why it's a habit, right? So understood. It's not a minus voltage, it's actually a plus voltage, right? A 5 volt. That means the VBUS is okay. Now we just flip the motherboard and see the VBUS is enter the IC. So we go to the Borneo again. VBUS, here you will see the VBUS line comes from here. There is a OVPIC. After the OVPIC, so this resistance or coil, right? After this capacitor, the VBUS line enter 2 point, right? From near the dot, right? So let's check it. So here, let's go to the under the microscope. So this is the OVPIC, right here, correct? So in that point, you will see VBUS line 5 volt here. On that side, there is a also. That means the OVPIC is complete. Now we check 5 volt on wall number 1, where the dots start, and 24 last pin. There is a 5 volt here. There is a 5 volt here. That means this IC, because this IC is a pin IC, so you can easily measure on the pins, right? The 5 volt. That means the VBUS is enter. Now we go to the Borneo again. Now after that, there is a VPH from this coil, right? And from these capacitors, and there is a VBAT line. Nothing, no more lines. So we check first, or VPH is there or not. Right now, I'm not connecting the battery. Let's move to the microscope camera. So this is the coil. There is 2 caps for VPH, right? 3.4. You can measure also in this coil 3.4 voltage, right? That means the VPH is generated. Now the VBAT line here. Now VBAT does not generate, reduced by this IC. Look at again the Borneo for the confirmation, right? These are capacitor or these 2 pins. Let's go to the microscope. Right here, right? These capacitor, right? And this one, no. So VPH is there, and but there is a low VBAT, right? Now in the hardware solution, that's zero. So how can you repair this one? So we take go to the Borneo, and we need another model. Now I'm up on the Borneo, and we need another model which has a similar IC. In this model, just a second, I will show you in a microscope. In this model, there is a IC number. Let me clear this. I will clear this first. Now this IC number, just a second, clear this. SN, right? SGM4. It's SGM415, right? It's a BQ series IC, actually. So this IC, a BQ series, similar to 25601. As already I made a video in my earlier days on YouTube, around about my 3rd and 4th video, about this IC. How this IC works, each and every detail. If you look at this video, you get all information, each and every pad. You can easily, now if you watch the video, and you will understood how the theoretical parts are important in practical. I mean to say in repairing, right? So if your fault comes and you know the theory, you will easily diagnose and you will fix the point. Otherwise, you will find on a solutions YouTube for other person, depend on other person. That is not a good thing. Make your base strong. I'm always says to you, make your basics strong, right? 70% of the repairing basis on a theory. If you replace this IC one by one, if you had a good design skill, sometime, most of the time, you will also stuck in a fault finding. But if you know the base, if you know how the schematic works, right, then you will easily fix these type of these situations, and you make a good money. Because if this kind of situation of any technician is kind of all like someone repair or created this situation, if I would ask the customer a good money, he will give me, you just fix the phone and I will give you good money, right? So experiences own benefits. So actually repairing is basically on a experience. So we go to the Borneo. Now in Borneo, if you see this IC had a bitmap also, right? But this bitmap, right? But for the understanding, I am explaining schematic. In this video, you will see how you use other schematics for the repairing, right? I'm already told you this solution had on a YouTube, but not this type of, what kind of video I made, a proper in detail, right? There is no shortcut. If you understood this solution, right? If you look at this video properly, whenever a phone comes to you, whatever model, right? You will never stuck. You will clear this. You will fix it easily. So I'm opening Redmi 5 as already made a video. If you do not watch a video of this, please watch a video, and you will, after this video, you will know how the better effect in your repairing life, how will change. So this is the layout of the 5A. First of all, we directly goes to the IC, right? Because this is a different model, and this is the BQ IC, and copy it in the schematics. Now this is the BQ one. As we already tested, 1 and 24 pin is a VBUS. Now 25 pin, there is a MID CAP, PMID. So we go to the bitmap. So this point had, let's say, show pad information, and this is the one. I'm already made a video how to count the IC walls from this kind of the IC anti-clock. From here, so 1, 2, 3, right? Here 24 and 23 pin is a PMID, as we see in the schematics, right? Now when you click this one, and there is a cap, basically 2 caps, right? On the upper side, let's go to the main camera. I mean to say microscope camera. So we directly measure on a pins, not the component. Pin number 23, remember, right? So it's a first point, right? So anti-clockwise 1, 2, 3, 4, 5, 6, right here. So that's how we count the ball. But we had a 23, let's say 24, and that's a 23, and we measure a 23 here, 5 volt. That means there is a PMID on a 5 volt. Now PMID, already I'm telling you in a many times, if you will get a 5 volt here, that means you are from charging connector to the charging IC internally. This line is all clear, right? The VBUS is all clear if you get a 5 volt on PMID. Now after the PMID, let's go to the schematics. After that PMID, we need a switching line, basically a BTST cap, Bootcap, and the switching. There is a VPH, right? So let's, we found the VPH and the Bootcap, and there is a pin number 21, Bootcap, and 20 and 90 pin is a switching. Sorry, 20 hard, right. So we go to the microscope. Now under the microscope, pin number, just a second, I forgot. Pin number 21 21, 20 and 19. In 21, BTST, right? Also, if you copy this, and this is the BTST cap. So one side you get roundabout VPH voltage, other side you get a double voltage. Now just again go to the camera, microscope under. Now in a microscope, so pin number 20, 21, 20 and 19, 21, 24, right here, and 23, 22, 21. This is the BTST cap pin. So we get a BTST as 8 voltage. That means our BTST also work. On this point, you get a 3 voltage of VPH. Now, in this case, the IC has already a switching because your BTST cap, look at here, this one is the BTST cap on this side, 8 voltage, right? On this side, there is a VPH, a 3 voltage. That means your VPH is also working and the BTST cap, there is no problem. If there is a problem, first we replace the IC or replace the boot cap because there is no switching if we did not find a 8 voltage on this cap. But we found a boot cap. Now, in my every video, I'm always told you about the boot cap. Now you will see there is a, just a second, on this cap, 8 voltage. This is the boot cap. Similar pin on this one, 8 voltage. Now boot cap is also okay. So why this IC does not charge, right? Now let's back to the schematic again. And after that, we go to the VPH is also okay. BTST is also okay, right? Now a line come back to the V system, 15 and 16 pin, right? After that, the charging outline. When 15 and 16, let's measure this. There is a voltage or not. Let's go to the schematic again. Sorry, microscope. Now, under the microscope again, 15 and 16 pin. Right here. Just a second. There is a 24, 23, 22, 21, 20, 19, 18, 17, 16, 15. I'm just holding this like this, right? So 18 and 17, 16, 15. There is a 3.4 voltage. That means this line is also came back to the IC. After that, there is a VPH line. This one. But there is a no VPH. This IC does not produce the VPH. Now in that case, you can replace the IC, but the switching is almost complete if you check the boot cap. Right? Now, there is another chance a line open from the IC, but we already check under the pads, not any component. So this is not possible, right? So because if we check under the pad, that means this line is connected to the outside of the component. Now VBAT is not generated. Sometimes VBAT generate when the battery connected, right? But we measure all other things because this phone taking amperes, it shows logo also in a on condition, also in the off condition. After that, in a sleep mode, it's dropped the charge. When you connect a charge, it's also taking a little ampere, a little consumption. Let's go to the, again, now we start from the one side, one by one. Easily, you will understand, right? Now, 1N24 VBUS is complete, PMID is complete, right? Now, there is a third pin called PG, right? Now, in this line, third pin, just a second, we go to the microscope camera. PG means power good, a negative signal, a cable connecting signal, also called system good. Right here, because this is a negative signal and you cannot, this line connected to the power IC. For more explanation, you can watch the video. I'm just removing right now a charger and checking a diode value, whether it's line connected to the charger or not. I mean to say in a diode mode. whether this line connected to the power IC or not. So third pin, 1, 2, 3. So this line is connected because there is no voltage. Because for more explanation, you can watch my video on YouTube. Basically, third video about the charging IC. I will I will show you an image. Now, after that, we go to the Borneo again. There is a status NC and 6, 5 and 6 SDN, SCN, right? So this line come from a CPU, right? Communication lines. Now get back to the microscope. Now SDN, SCN, 5 and 6. First, we measure diode value. So there is a value 499,517, right? A little similar. Let's measure the voltage route. Now in a DC voltage mode, multimeter. Now there is a 1.7, around about 1.8 approx. There is a 1.8. Both lines had a 1.8. That means the SDL SCL line is also connected. Clear? Now let's go to the again a Borneo. Now after that, there is an interrupt. Now interrupt line. This line is a 7 number. So let's go to the camera. Now let's measure this pin in a diode mode first. Now this line had a 499, a diode value. That means this line connected to the CPU. Right? Basically, this line comes from a charging symbol. Appear the charging symbol. Right? But we had a charging symbol, so we did not work on this line. Right? Now next. Now after that, there is a NC and the charging enable. Charging is already enabled. And the second pin called PSEL, power source selection enable. Right? In this line, you will get a divider circuit, but this cap is NFI, right? Not fitted. We go to the bit map and see the second number pin. If in this model there is a second right here, two caps making a divider circuit in this line. Get back to the Borneo for more understanding. Click the RGN line and next. Just a second. Second number pin, RGN. So RGN comes from the 22nd number pin. This is a regulator voltage line, right? Now that means on a 22 pin, you get 5 volt. Also, on a second number pin, there is a divider circuit. Now first, we measure a 22 pin because this pin comes from 2 number pin, directly comes from the 22 number pin. Camera and the camera and 22 pin. So this is a 22 pin, 24, 23, 22. Just a second. On a voltage mode, measure the voltage on a 22 pin. Right here, 23, 24, 23, 22. Right? The 5 volts. As I already told you, there is a MOSFET here. So from PMID to on this one, you will get 5 volts. Right? Now, pin number 2 or 2. Let's again go to the Borneo. Let's again go to the Borneo. Yes, pin number 2. Now go to the microscope again. On to the microscope. Now pin number 2. There is a 2 resistance. Right? Now pin number 2 had just a second. First, second. Alright. You will get 5 volt. Now there is a divider circuit. let me clear this. On a now in a Borneo, we had a bitmap. Now there is a two resistance. If both resistors working, there is a lesser voltage because the divider circuit work. Everybody know the divider circuit formula. I'm already made a video about this also. So let's look at the charging motherboard section. There is a pin number 2. This one is the main resistance and this one is the NC. So that's why it's a 5 volt here. Also, when you look at the schematic, there is a NF not fitted. So there is a 10K resistance only. So 5 volt here. Let me show you again in a microscope. Pin number 2 and this resistance at a 5 volt connected to this line at a 5 volt. If there is a NC, this resistance and 10K resistance, if installed, then the divider circuit works. Right? Then the voltage divide here on this point. But there is an NC. Right? So no component on a divider circuit, on a pull down component, pull down resistance. R2 is not installed by the company. That's why you get 5 volt here. Now get back to the schematic again. Now after this, from here, pin number 11, this line also come from the RGN. That means in this line you will get a 5 volt also, right? There is a 210K resistance. That means there is a divider circuit formula apply, right? So what is the divider circuit formula? I will tell you. Wait a second. After we check this on a microscope, this point, I will tell you a divider circuit formula. Now, we check in a microscope. Let me enter the microscope, pin number 11. Right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this one is 11. Right here. There is a 5 volt, but there is a 2 resistance, right? Creating a divider circuit. That means there is a divider voltage divide here. How? I will tell you. Let's go to the Borneo and the bitmap. Maybe in this model, Redmi 5 company use this, but on the own model, but in a Vivo, maybe company does not use. So for the confirmation, we go to the bitmap and pin number 11. So this number, pin number 11, TS. So there is a 2 component here, right? Now we go to the charging section in motherboard. That both are installed. Even a microscope, in a microscope, let's look at the both components are available in these two. I will show you. Just a second for the clarity. Now let's check on a resistance mode. The both component had a similar value. Maybe any component value gain. Oh, this is a 10K, right? Now this one is also a 10K, right? For the clarity, just a second. We are confusing formula. It's also a 10 kilo. Both resistance are 10 kilo. Now resistance are okay, but there is a no dividing voltage. Voltage not divided here, right? In both components, in between these 2 points, right? In between these 2 points, voltage dividing must. I need. Let me show you how divider circuit formula work and explain you this thing. After that, with diagnosis, we go to the Borneo. Now pin number 11, I will show you how in this sub pin there is a divider, right? I will show you how the divider circuit formula work. So we need a voltage out, right? V out. So the divider circuit formula in a series, when 2 and more than 2 resistance, right? Just a second, clear this thing. My drawing. Now V out, we need a voltage out. right? Now voltage out, the formula is voltage in. Now simple, I will tell you first. Now when a series, two resistance and more than two resistance attached like this, suppose in this line are two resistance, right? R1 and R2, 1 and 2, and both resistance connecting in a series, and one resistance, first resistance connecting in a main line, right? And the second resistance is connecting in a ground. This is our pull up resistance and this is our pull down resistance. Voltage in this case, we had a 5 volt from RGN line to TS line, pin number 11. So this is the divider circuit formula is voltage in, right, multiply by R2 value 10, R1 divided by R1 plus R2, right? So in that case 5 volt voltage in, R2 value 10 divided by 10 plus 10 equal 50 by 20. So in that case, in this value and 2.5, we need 2.5 voltage on TS pin, pin number 11, right? Clear? Now pin number 11, let's go to the schematic. Why this pin is important? It's a thermal sensing pin, right? A temperature sensing pin. When there is any component damage or both of these resistance, any damage or missing, right? The voltage on this line get a 5 volt, right? So when the 5 volt here of the CPU sense through SD and SA line, this IC gets heat, something get wrong here. For safe side, this cut off the, I mean to say deactivate the IC, not charging, right? A simple. I hope everything will be clear. For the more information, you can watch the video from each and every detail. When the 5 volt here, CPU says there is something wrong. That's why it's cut the switch off. Now, how? There is in our case, both resistors had a similar value, 10K. No problem. Both had connected. No one missing. So how can possible this divider circuit not work? Let me show you and check the in a microscope. We check on a diode mode value. So our first resistance, just a second, I will clear to you. The R1. The R1 is here. This one. Right? So just a second. So this is the R1. R1 had connected to the VBUS. And this is also connected on the other side. Now this is R2. This is also connected to the, this is also get a value, a diode value, 5 to 5. That means this is also connected. Now other side, you get oil value. But on this side, this line connected to the ground, right? I will show you in schematics. This component had a ground. I will show you in a bitmap also, right? The first one connecting to the ground right here. Now this line from this is R1 and this line come from RGN pin, right? Also PSL pin number 2. Similar line connected. I will show you. I will tell you in a drawing so you can better understand, right? Let's draw this. Let's suppose this is a BQIC. 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. So this is the dot. Bootcap okay, VBUS okay, VBAT does not generate, PMID okay. So pin number 2, REGN line. In this line, you will get a 5 volt here, right? Or pin number 22, sorry, pin number 23, I thought. So whatever, the RGN line comes from a resistance, right? And this line comes from PSL, power source selection line, pin number connecting to 2 pin. This is also a 5 volt here, 5 volt here, 5 volt here. Now this line again connected to the 11 from 6, 7, 8, 9, 10, 11. Now there is a 2 resistance, right? And this resistance connecting to the ground. In between, a line emerge and connecting to this center point. Now 5 volt here on this point. After divide the formula, divider working, in this line you will get a 2.5 volt. But in case the ground is missing because somebody on a peeling time, when remove the shield, they peel the layer. So ground cut it, right? So that's why in case when the ground miss, the pull down resistance does not work. So in that case, we had a 5 volt, right? That's the reason CPU sense when the 5 volt is here. That means there is a thermal issue, heating issue. So when you connect the charger, charging logo appear. After that, CPU shut down this IC. Does not work properly. So do not charge. So I hope you get it. If you had more information, if you want more information, then watch the video regarding this charging IC. Now, this is the second resistance, the ground missing. Let's check the ground connected or not with the add value mode. Let's go to the microscope. Thus, under the microscope, and now we check the ground. There is a ground connected or not. Multimeter on a diode mode by red probe on a ground with the black. There is a value, but not a ground. So we create a jumper here, right? And see whether the phone working or not. So we connect a jumper from this resistance to this capacitor, ground point. Right? There is a ground point, and we connect a jumper from here on a ground side. Because the ground, someone removing the shear time, the period. Right? Now we check on a multimeter. The ground is connecting or not. So there is a ground. Right? Now we check the voltage. The voltage divided here or not. Now, check here. On this, there is a 2.3. Right? Before 2.5. Now let's check the pin number 9. 6, 7, 8, 9, 10, and 11. 2.3. Right? Now we connect, go to the main camera. Now let's pack this phone, connect the display and battery. Now we connect the battery here. And let's see if the phone charge or not. Now we connect the charger. And the charging starts. It's taking 4 ampere, the charging logo ampere. Now let's see this charging stable or not. Now it's taking 1.8 ampere. After the screen goes turn off, but the ampere takes 1.8 fast charging, right? When we press this, okay, 1.5. When the screen goes turn off, let's see. It's still taking ampere. That means this phone is complete. The fault comes from the TS line, right? Now we turn on the phone and let's see it's charging on a turning on condition properly or not. Now phone turn on. After the turning on, we connect the charger and let's see. Now the phone getting start. Now the phone is completely okay. It's taking charge while the screen off or on, and it's taking fast charge, right? 1.8, 1.6 round out. Now phone is turning on, and let's connect the charger again. Now look at this. It's taking charge, connecting charge, and it's taking 1.6, 1.4. Before it's taking milli consumption 0.200, 300. Now it's taking 1.2, right? 1.3, and the screen does not turn on. Remember, before the screen turn off, the charging automatically drop a little consumption also. When we press the button, it's similar. Proper charging. A charging logo also appears, right? So that means the fault comes from the TS line. When the ground is missing, the component is all remaining particular state. That's why I'm also in my many videos I'm told you the ground line is also important. Is it playing a major role sometime? So in that case, you will see. I'm already told you this solution is this solution already on a YouTube, but not this kind of the video in a full detail. There is a shortcut method you can apply if your phone fixed. That's okay in it. Otherwise, you go to the next solution. But why this solution comes? Now, this IC, we read a schematic on a Redmi 5A, right? And repair this phone, or Vivo Y15s. Compared to both phones are different, right? But the IC number is also changed, but the similar data sheet working on both phones. So VBUS version. So that's why through schematics we repair this phone. If we do not know the fault finding schematics, if we do not know the IC detail, how the IC work, each and every point, each and every detail, how can you fix? If this is a different model, and you will be stuck that time if you do not know the schematics. Why the schematics and why the theory important? In that case, you will see. Right? I hope you will like this video. And if you like, then share this channel from other technicians. So this is a normal case. Even I will fix in a 10 minutes because I'm already fixing many phones in that condition. But for the video, I will make a full diagnosis for you. Now in that case, you will see why not removing shade in that way. What was the harm? Suppose removing shade, there is a MIPI lines directly connected to the CPU, under the CPU, and 5 or 6 track open. How can you fix this phone? For this, you can open the CPU and under 5 to 6 jumper lines from the display connector. So there is a lot of hard work, right? So I've already made a video about on how to remove shade in a perfect professional way, right? Always work clean and professionally. I'm just saying that. And schematics is also an important role play. If you know the schematic, you know the answer why. Why is this? Now, 90% technician do not know if they take the jumper, right? Suppose, for example, from YouTube, if the solution, if they connect a jumper, but why? Which line causes the problem? How this happen? How the phone fix? Which line cut, open, short? Why? The question why. They only knows, they know the schematics, and only that person provide the solution on YouTube. After that, they again copy and copy and copy. Just someone take a jumper from theory basis and they applied it, and other poor technician come to and take a little part or short part, just only a solution. If the solution work, then he get the fix the phone and watching the next. But they do not know how this phone fix. So in this video, I'm giving you a full detail. So I hope you will like it. And if you learn something new, share this channel, like, and give a lovely comment. Thank you so much. We will meet you in a next video.